sum is going to be the total terms, 100 divided by 2, times my first term plus my last term, which is going to go ahead and equal 50. So 5,050. All right, make sure you know how to do that. Should be one of the easiest things on the test when I ask for the sum of an arithmetic sequence. Now I want to bring something up really quick. So this is the sum of an arithmetic sequence. I need to know the last term. If I don't have a last term, let's say it goes to infinity, you can't do this sum. All right, which makes sense because if I keep adding a number over and over and over, that number is just going to keep bigger and bigger and bigger. I can't come up with a sum. It's just going to be infinity. Just like if I'm subtracting a number over and over and over, it'll just keep going more and more negative. So if this goes to infinity, we can't actually come up with a sum. The only thing we can do with arithmetic functions is if it's a partial. If I know a start point and an end point, then I can come up with the appropriate sum. All right, what questions did we have from the homework? Yeah?
So then, like, if that's true for like 69 and 70, is it just infinity?
First of all, there's I think those are the ones that actually didn't put the right thing over. Really quick, let me get to it. Because you've looked in the answer guide, they had a weird answer because I didn't put what you're supposed to do on it. It's 69 and 70, right?
Yeah.
These were actually, you're supposed to find the average, the mean of them, kind of thing. But it does have a stop point. We just don't know where it stops. So what I would do, if I had to come up with the sum of 1 through n, I would just say S sub n would equal n over 2 1 plus n. So that actually is the equation. If I knew what this number was, I could plug those guys in. All right, kind of the same thing with that one. I would just end with 2n, and I would just have 2 here in its place. All right, if I had to come up with the sum. If I had to come up with the average, I would just put it over n or something. Okay, so don't worry about 69 and 70. I put them in the wrong place, and I didn't really give you the directions. But if you're required to come up with the sum, that's what it looked like. All right, other questions? Yeah?
Can you go over 79?
79. So 79, which is actually 77 in your book. If you looked up the answer key, you would have noticed that it was actually 77. So it says the annual payments for Wilma deposited $1,000 into an account paying 5% compounded annually each January 1st for 10 consecutive years. So this you had to remember something from Algebra and Algebra 2. And that is when you're compounding something annually, you're adding. So I'm adding 5% of this total each year. Well, the equation for that is going to be 1,000. This is our compound formula times 1.05 to whichever year you have. This will be how much you have in any given year. All right, so my first year I'd multiply this whole thing by 1.5, which I'd add 5% to it. So that means the sum of all the years together would be, I'm going to start on year 1. And I'm going to go, how long did it go? 10 years. To 10 would be 1,000 to the 1.05 to the end. That will account for everything. Okay? So we start with 1,000. So in year 0, which we're not going to actually count, this would be this to the 0, so it would just be $1,000. After my first year, this would be a 1. So it would be 1,000 times 1.05, which would be a 5% boost. You have to remember the 1 on it. Because if you forget that 1, you're actually going to be calculating how much in addition you'd have. All right, so on my first year, this would actually be $50. But I don't want to have a total of $50. I want to have a total of $1,050. So you have to use that to hold on to your 1,000, and that would be your 5%. All right, does that make sense?
Yes.
Okay. Other questions? No? Okay. We'll go into today's lesson. I do want to remind you real quick that test corrections are due today. And also, if you haven't already, and if you're sick of hearing this, take it already. The survey. Take that survey. I reposted it on Edmodo. We're at like 75%, so at least we're passing. But I'd rather that be 100%. I'd love it to be 100%, but I always shoot for 90% completion. So 24%, math says that someone in here, at least one person, didn't take it. So let's go ahead and take it. It takes literally less than 5 minutes. Okay, geometric sequence. So with an arithmetic sequence, all I was looking for is, did I add or subtract by that same number over and over and over? Geometric sequence, once again, is a sequence, but the consecutive terms have a common ratio. They're going to have a common ratio. And what I mean by ratio is it's going to be multiplication. Instead of addition and subtraction, we're going to be using multiplication. We're really looking for multiplication. So that means to get from one number to another number, I have to multiply by a number over and over and over in order for it to be a geometric sequence. So I'm going to jump right down to our examples so you can see what I'm talking about. First of all, I'm going to scratch out that arithmetic statement. We're actually looking for geometric. That's kind of a reverberation of copying and pasting. All right. So we look at that first one. It's 1, 2, 4, 8. The first check I'm going to do is I'm going to see if it's arithmetic. In order for it to be arithmetic, I'd have to add the same number over and over and over. Well, this would be plus 1, plus 2, plus 4. It's not arithmetic, so I'm going to go a different route. Now I'm going to check to see if it is in fact geometric. And so I'm going to look for multiplication. And I'm going to say to get from 1 to 2, I multiply by 2. And in order for it to be geometric, I have to multiply 2 all the way across. So 2 times 2, yep, that's 4. 4 times 2, yep, that's 8. So this is in fact geometric. And our common ratio, with common difference, we use a D. With common ratio, we're going to use an R. So my R equals 2. That's my common ratio. Once again, the next one I'm just going to ask myself, is it arithmetic? And there's no number I can add or subtract that gets me from 1/2 to 1/8 to 1/32 to 1 over 28. So it's not arithmetic. So the next thing I'm going to check for is it geometric? Well, to get from 2 to 8, I multiply by 4. So if I multiply this whole thing by 1/4, I get 1/8 out. If I multiply 8 by 4, I get 32. So this is also multiplying by 1/4. And I just got to check one more place. If I multiply 32 by 1/4, it equals 1 over 128. So this is also geometric. And our common ratio equals 1/4. Now make sure you're going through these checklists. All right, is it arithmetic? Is it geometric? Otherwise, it's going to be neither. Because on the test, I'm not going to give you a geometric section and then an arithmetic section. I'm going to put them all together and say, can you tell which is which, and come up with formulas for them. All right, just like any other sequence, we have two ways we can express it. We can express it using a recursive formula, or we can express it doing an explicit formula. Our recursive formula is going to be the term I want, a sub n, is going to be the common ratio times the term before it. That is our recursive formula. Remember, if I do a recursive formula, I do have to say a sub 1 equals some number, right, to be 100% correct. But we're not going to put, I guess we could put an example. So make sure you list that a sub 1 equals some number. We'll call it x. All right, our explicit formula. That's just going to be a sub n equals our starting term times our ratio to the n minus 1. Bless you. And that's it. So all you need to know for the explicit formula is your first term and your ratio, and you just plug it in. All right, a couple quick examples. We're supposed to list the first 4 terms of this guy. So our very first term would be a sub 1 equals 3 to the first, which equals 3. A sub 2 equals 3 squared, which equals 9. A sub 3 equals 3 to the third, which equals 27. And a to the fourth equals 3 to the fourth, which equals 81. Now I'm just going to check to make sure it's geometric. Well, to get from 3 to 9, we're going to multiply by 3. To get from 9 to 7, we're going to multiply by 3. And to get from 27 to 81, we're also going to multiply 3, but so it's, for a fact, geometric. And we could have also noted, hey, it's 3 to some value. You guys need a pencil?
Yeah, we're kind of sharing.
Are you guys sharing a pencil? That doesn't seem the most productive way to do it. Alright, so it is in fact geometric, and we also knew it was geometric because if we look right here, I have 3 to the n. Anytime you have a number to an n, a number to the n minus 1, a number to an n plus 2, number to a 3n, it's automatically going to be geometric. Alright, so if it's an exponential function like this, where we have 3 to the n, 3 to the n minus 1, anything that looks like this, it's going to be geometric. So in fact, just looking at that next one, I already know it's for a fact geometric, because we have some number to the n minus 1. That tells me right off the bat that this is geometric. It's got to be. All right, I'm just going to double check that though. So we're going to say our very first term is 100 to the 1 over 2 to the 1 minus 1. Well, 1/2 to the 1 minus 1 is just 1, because 1 minus 1 is 0. 1/2 to the 0th power is 1, so we just have 100. The next one is 100 times 1 over 2 to the 2 minus 1. Well, that's just 1/2 to the first power, so that's just going to be 1/2, so it's going to be 50. A sub 3 is going to be 100 times 1/2 to the 3 minus 1. Well, that's 1/2 squared, which is 1/4, so it's 1/4 of 100, so that's 25. That says 24. This says 25. And finally, a sub 4 is going to equal 100 to the 1/2 to the 4 minus 1, which is 1/8 of 100, which is 12.5. So to reconfirm it's geometric, I would note that we're going to multiply by 1/2. I'm going to multiply by 1/2. I'm going to multiply by 1/2. So not only can I look for the 1/2 here, I also know I should have multiplied by 1/2 to begin with. Whatever number is attached to my n is going to be my common ratio. So that means whatever number is attached to my n here better be my common ratio too. So we have 3 to n, so I must be multiplying by 3 over and over and over, which I am. Alright, so this is our common ratio that matches up with this. This is our common ratio 1/2, which matches up with those 1/2s that we showed after we found our first 4 terms. All right, then moving on. Writing formulas in a general term. Note that statement right there, general term. General term tells me I'm going to use the explicit. General term means explicit. All right, make sure you listen to me. General term means explicit. I should see some writing down of stuff. Because if I put that on the test and you don't know what I'm asking, I told you to put in your notes. All right, general term is explicit, so we're going to do our explicit formulas. So I have my starting out term as 0.3. I just need to find my common ratio, if I can find one. Well, 0.3 divided by 10 equals 0.03. But I don't want to use division, I want to use multiplication. So I'm just going to say, instead of dividing by 10, I'm going to multiply by 1 over 10. And then I'm going to multiply by 1 over 10 gets me 0.003. And if I multiply by 1/10, again, I get 0.003 as well. So this is, in fact, geometric. So my explicit form is going to be a sub n equals my very first term, which is 0.03, or 0.3 I should say, times my common ratio. My common ratio was 1 over 10. So it's going to be 1 over 10 to the n minus 1. And I always, as soon as I come up with a explicit form, I just check to make sure it is correct. If I plug a 1 in for here, that means my first term is what I'm looking for. So if I plug a 1 in here, I plug a 1 in here, and we have 1 minus 1. So I'd have 1 minus 1 if I plug a 1 in here, which would give me 0.3 times 1, which is my first term. So that is, in fact, the correct equation. All right, my next one is 2, negative 6, 18, negative 54. If it was arithmetic, how do I deal with that positive negative? How do I deal with positive and negative if it's arithmetic? One person remembers? 2 people? I can wait. Look it up if you don't know. If you don't know right now and you're just sitting there, look it up. Because this is important. If it's arithmetic, how do I deal with the positive and negative? Mike?
Negative 1 to n.
Yep. Negative 1 to the n, or the n minus 1, or n plus 1. That's how we deal with it if it's arithmetic. This is different if we're dealing with geometric. Because geometrics already lets us multiply. So with geometric, I don't have to worry about the negative positive. I'm just going to say, well, 2 times a negative 3 equals a negative 6. And negative 6 times a negative 3 equals a positive 18. And finally, 18 times a negative 3 equals 54. So my common ratio is going to be negative 3, because this is, in fact, geometric, because we're multiplying by the same number over and over. And so my explicit form is going to be a sub n equals that very first term times negative 3 to the n minus 1. All right, my next one does not look geometric. Because I'm going to have to multiply by some weird fraction to get from 6 to 8, and that's not going to work from 8 to 10. That's not going to work from 10 to 12. So it's not geometric. And if I would have done my checks, I would have said, well, this is actually plus 2, plus 2, plus 2. So that, in fact, this is arithmetic. Well, if it's arithmetic and I have to write an explicit form, I'm going to have a sub n equals my common difference. Well, my difference is 2. plus c. Well, c is my first term minus my difference, so it's 4. Once again, I keep writing this because people are going to mess this up. This is 6 minus 2, which is a sub 1 minus my difference. Alright, last one looks more geometric because it doesn't look like I'm going to adding to get to 1/6 and then adding to get to 1/18 and then add to get to 1/54. I can't use that same number. So we're going to look for multiplication. And this is going to be times 1/3. 6 times 3 is 18, so this must be times 1/3 as well. And 18 times 3 gives me 54, so this must also be times 1/3. So my common ratio is 1/3, and it is in fact geometric. Alright, so my common or my explicit form is going to be my first term times my common ratio to the n minus 1. And these are things we're going to have memorized, right? We're going to have to memorize how to come up with the explicit form of arithmetic, and we have to memorize how to come up with the explicit form of our geometric sequence, along with our recursives. All right, our next three, and I'm probably not going to go through all three of these because it gets a little redundant because we know how to plug numbers in. But it says find the first 4 terms of each sequence and determine if the sequence is geometric. Well, like I said before, if you see a number, so I have negative 2 to the 3n. Since 3n is in my exponent, it has to be geometric. So I already know before even going into it that it is in fact geometric. But let's go ahead and do at least the first couple. So b sub 1 would equal negative 2 to the 3 times 1. Which would equal, well, it's negative to a third power, so it must be negative. And it's going to be negative 8. Alright, b sub 2 is going to equal a negative 2 to the 3 times 2. And that's going to equal, is that 64? I've already lost my sheet. Is it 64? Yeah. Okay, thanks. It's a positive 64. And then b sub 3 is going to equal negative 2 to the 3 times 3, which is going to be 9. Negative 2 to the 9, which would be negative. And can someone give me the total for that? 512. I'm going to stop right there because it is geometric. We already know it from that. And we're actually going to multiply each term by negative 8 times negative 8. And we would just keep multiplying by negative 8. And so it is in fact geometric, but we knew that going into it. We knew it was geometric before we even started. Okay, for our next one, our first term is 1.25. I'm not even going to do this one. I'm just going to note this right here. You can plug in numbers. I believe you can. I'm going to notice it says negative 2 times a sub n minus 1. Well, we already said our recursive formula is our rate times the term before it. So the term I want equals our ratio times the term before it. Well, that's the exact setup here, so that has to be geometric. That has to be geometric. Okay, and our very last one, I have c sub n equals 3n, so I'll do c sub 1 equals 3 times 1, which equals 3. C sub 2 equals 3 times 2, which equals 6. C sub 3 equals 3 times 3, which equals 9. And finally, C sub 4 equals 3 times 4, which equals 12. Well, this is definitely not geometric because I am just adding 3 plus 3 plus 3. So in fact, this is arithmetic. And if you remember anything from being arithmetic, it's a linear function, and this is a linear function with a slope of 3, so it has to be arithmetic. So the two big differences between these two, if it's an explicit form, geometric is going to be some number to the n power, whatever n it is, 3n, 5n, n minus 1. And our arithmetic is going to be just 3 times n plus something, some number times n plus something. All right, that's how we can easily tell in explicit form what we're talking about. All right, the very last one is a word problem. But it's just setting up a geometric sequence. It says a ball rebounds 2/3 of the distance from which it falls. If the ball is dropped from a height of 9 feet, then the observed rebounding to a height of 64 over 81 feet. How many times did it bounce? So in other words, I just dropped a ball from 9 feet, and the very last bounce I could actually measure was 64/81 feet. All right, so that was the last bounce I could observe, and then it kind of did that dribble thing where you can't count the bounces anymore. I just want to see how many times did it actually bounce. Well, we need a starting value. I need a starting value. I'm going to tell you right now it's not 9 feet. Yeah, it's going to be 6 feet. Yeah, because our first term has to be one bounce. And if I didn't drop it, it didn't bounce yet. So our very first term has to be that first bounce. Ooh, I kind of boxed myself in there. A sub 1 is actually my first bounce. So it's not my initial height, it's my first bounce. So that would be 9 times 2/3, which equals 6. My very first term is 6. And it's obviously geometric because we're multiplying by a number. What number are we multiplying over and over by? What is our common ratio? Yeah. It's 2/3. Yeah, our common ratio. So our first term is 6. Our common ratio is going to be 2/3. So I can come up with an explicit formula. And my explicit formula is going to be a sub n is going to equal my first term, which is 6, times 2 over 3 to the n minus first power. Well, it didn't ask me what's the formula. That could be the problem. That could be the question on a test. I could just say, come up with a formula that models the ball, and you'd be done. However, this one says specifically, hey, the end, my very last value was 64 over 81. So what we need to do is I'm going to go ahead and slide this off. And I'm just going to say, well, I don't know what term 64 over 81st is. But we're going to go ahead and check it. So we're going to do 6 times 2 over 3 to the n minus first power. All right, so my very first step would be divide both sides by 6. I'm going to divide both sides by 6, which is going to result in, so my very first step is divide both sides by 6. That's going to result in 64 over 486. Which we can actually simplify down to 32 over 243, and that's going to equal my 2/3 n minus 1. Now pay attention closely to this next step, because although there aren't word problems on there, we're going to have problems that look just like this, all right, that ask you to solve this equation. We have two ways we can solve it, but we're not going to go one method. We can use logs. We can use logarithms to solve this, because logarithm is the inverse of this. So we could take log base 2/3 of both sides and get that by itself. We're going to solve this a different method, because we already did logarithms. We're going to solve it a different method, and something you have to reach back to algebra 2 for. I have 2/3 to some power. I want to see if I can turn this into 2/3 and see what power that would go to. Well, 2 times 5 actually equals 32. And 3 times 5 actually equals 243. I'm going to go ahead and write that on the bottom. 2 times 5, or 2 to the 5th power, I'm sorry, equals 32. And 3 to the 5th power equals 243. So I can rewrite 32 over 243 as 2 over 3 to the 5th power because of this fact, which is going to equal 2 over 3 to the n minus 1. Now there's an exponential property that says if you have the same base, if I have 2 to the 30 to the 5th, and I have 2 over 3 to the n minus 1, same base, same exact base, is going to let me just say that 5 must equal n minus 1. So that means my n equals 6, and so it was 6 bounces. It took 6 bounces. All right, and you will have to do this in your homework. All right, so you're going to be set up just like this, where you make sure everyone's paying attention. You have to do just like this, where you have to divide a number on both sides, and you have to make this have the same base. We're going to make the same bases, and more primarily, it is going to be these two formulas are the big ones. All right, they have to do those steps for. I'm going to tell you right now that there is a way to use your calculator to do that for you. Do it by hand first, and then try your calculator. We're going to go over the calculator usage on Monday or Tuesday, depending on when we can get to it. Probably Monday, all right? But it involves just plugging in a formula into your y equals and using your table function just to count how many steps it takes to get there. All right, let's go.